Welcome to Module 4, which is Systems of Equations and Systems of Inequalities. We're going to first talk about solving systems of equations using elimination. So, a system of equations is two or more equations with the same variables. Typically, they are x and y. Graphically, if we're looking at a solution, it's a point xy where the two lines intersect. And algebraically, the point xy that makes both equations true. So the elimination method is a method for solving systems by adding or subtracting to eliminate a variable. So let's talk about some steps. So you want to first make sure the equations are lined up so the x's are together in a vertical line and the y's are together in a vertical line, and then the constants are together in a vertical line. And then you're going to add or subtract the equations to eliminate the variable with common coefficients. Step 3, you're going to solve for the remaining variable, either x or y, and then you're going to substitute your answer, so whatever value you get for that variable, into either original equation and then solve for the other variable. So let's look at some examples. So we have y equals 3x plus 4, and then y equals x minus 2. So the y's are the same, so that means I can subtract them to get rid of them. So this is going to be y minus y gives me 0, so I'm just not going to write anything. And then this minus sign also goes to the x and to the 2, so this would be 3 minus x, 3x minus x, which is 2x, and then 4 minus negative 2, so plus 2 would be 6. And so then I'm going to solve for x, so subtract 6 from both sides. X is, and then divide by 2, x is negative 3. So now that I have x is equal to negative 3, I'm going to plug it back in to either this one or to this one. It doesn't matter. I'm going to use this one just because it's simpler, but it doesn't matter which one you use. So y equals negative 3 minus 2. So y equals negative 5. So my ordered pair is negative 3, negative 5. All right, moving right along, I have here 4x plus 2y equals 6 and negative 2x plus 2y equals 18. So once again, my two y's, they're lined up, so I don't have to do anything. My two y's are the same, so I'm going to subtract. So 4x minus negative 2x gives me a 6x. Those go away. 6 minus 18 gives me 12, negative 12. So then divide by 6, and x is equal to negative 2. And then I'm going to plug negative 2 back into either equation. I'm going to pick that one, but you could pick either one. So 4 times negative 2 plus 2y equals 6. So I get negative 8 plus 2y equals 6. So add 8, 2y equals 14. So y is 7. So my solution is negative 2, 7. All right, so that's that one. Moving right along. So this one here, the y's both have the same one coefficient of the variable, but one's positive and one's negative. Positive, negative, I said that backwards, but so I'm going to, instead of subtracting them this time, I'm going to add them. So x plus 3x is 4x. Those guys go away, equals 28. And then from here, why don't you take a second and solve that? So you're going to divide by 4. So x is going to be 7. Plug it into either equation. I pick that one. So 7 minus y equals 10. Subtract 7. both sides. Negative y equals 3, so y equals negative 3. So my solution, or my ordered pair solution, is 7, negative 3. Alright, so those are all lined up for me, but if we look here, I have a y and an x on top of each other, and an x and a y, and plus my equal signs are in different places. So let's just get them all situated. So I'm going to subtract the 2x to the other side. So I'm going to have negative 2x plus 4y equals negative 8. And then this second equation can stay the same. So I have 5x minus 4y equals 20. And so from here, I want you to solve it. So you're going to end up adding these equations. 5 minus 2 is 3x. Those guys go away. 20 minus 8 is 12. Divided by 3, x is 4. So when x is 4, we want to solve for y. Doesn't matter which one you use. I'm going to use that one. So 4 times 4. Nope. I forgot the y. 4y equals 2 times 4 minus 8. So 4y equals 8 minus 8. So 4y equals 0. So y is 0. So my solution is 4, 0. Alright, and then these guys have the same sign, so I can subtract them. So I'm going to get 0x. Well, look, hang on. All of my variables cancel, so those cancel and those cancel. I'm going to have 0 equals negative 10 minus negative 13 is 3. 0 never equals 3, so I have no solution. I have no solution because if I wanted to graph these, they would be parallel lines. Let's do this last one here. So 2x plus y equals negative 10, and negative y equals 2x plus 10. Well, I want to get them to be the same. So let's keep the top one the way it is. And then let's subtract the 2x to the other side. And so I have 2x and a negative 2x. So we can add those. So those are going to go away. With positive y and a negative y, so those go away. So I have 0. Negative 10 plus 10 is 0. So 0 equals 0 all the time. So I have infinite solutions. And if I graphed those lines, they'd be the same. That's why I have infinite solutions. We'll talk about what they look like on a graph in a little bit. So this is just the first video. There'll be a second video that you need to watch to get the exit ticket password.